Evening, my warriors. How is everyone? Let me know if you can hear me. Let me know if you can see me loud and clear. Welcome aboard, all my warriors, to the wonderful session of capacitors. This is lecture number 2, where we are going to discuss energy, dielectrics, energy consideration, heat losses, and energy density. A very, very important topic in capacitors. It's a very important chapter from JEE Mains, from KVPY, and JEE Advanced perspective. And I'm your physics master teacher, and my name is Shreyas, and I have been teaching for a very long time, producing some amazing results, sending kids to IITs, NITs, and you guys are next in line. So welcome. Hi PL, Steve, Joel, Anushrut, Surya, Yatin, Janani, Sai Telugu, Minyanarthi, no problem. Hi Anil, hello Kiran, welcome aboard. How is everyone? How are you guys doing? Good evening Vikram, nice to see that you're very excited with all the fire. And yes, we are going to rock it. Hi Ankit, nice to see that your display pictures have changed. So all the people who do not have display pictures, you can get a cool display picture like Ankit, Vikram, Surya, Minyanarthi, and so many others out here. And that's like Sai Telugu also. The link for downloading the display picture is there in the description box below. All you need to do is download that image and set it up as your YouTube profile picture to show your support and love for all of us. Hi Hishwita, welcome aboard. Hello Munna Bhai, Janani, Divya, welcome, Kaveri, welcome everyone. Yeah, well Ankit, your comments are always very nice, and I see all your comments, guys. And it's, I think, also time you guys smash the like button and hit the subscribe button in case you have forgotten to do so. And the entire schedule, PDF, everything will be shared in our Telegram channel as well. Go ahead and join it. Now look at the schedule this week. So tomorrow we are going to have communication systems. That's for 2021 students, but you can also attend it. That's okay, provided you know a little bit about the chapter. These are the rank booster series. In case you have missed the capacitor first class, which was conducted on Monday, please go ahead and watch it. And special classes on Saturday and Friday, it's for the 11th standard kids out there. And remember, you can also pledge your support, which Vedantu has undertaken for all the kids who have suffered because of the pandemic out there. So help India learn, that's a Vedantu initiative, and you can contribute towards this cause. The link for the contribution is there again in the description box below. Now let's also have a look at the comments which you guys have put up for all of us. Let's just go to Enthuse channel, guys. Yep, let's do that. And let's go to our past videos and let's just have a look at the comments you guys gave last time. And there you go, there you have that capacitor, and that's me holding it. Okay, let's go have a look at the comments, all the beautiful comments. Sudarshan, when is the next batch for 2021? I think I replied. Ankit, I have replied. Venkata says super sir, thank you Venkata. And well Keshav, thank you, I have replied to your comment. We Enthuse FC says superb session, thank you. Hema, yes, we are continuing with PYQ series in the form of rank booster. And Chetan, well, I think a lot of you have replied to Chetan as well. So guys, you can post up all the answers in the comment section over here so that I can probably do a little bit of your publicity too. Hi Ria, welcome aboard. Hello Kavya, hi Lekhit. Is it easy to crack JEE if I'm consistent with my studies? Yes, consistency is the key. You should have, focus. You should also have the right mentor, the right content, and the right strategy. With that, yes, you can definitely crack not just mains but even advanced. Okay, in fact, this is what I want you guys to see, because see, a lot of people are hardworking, but there is something missing. Now that is what is missing, guys. Look at this. A lot of people in India are putting in their heart and work, but you can see the Vedantu students out here are outperforming the national average. In fact, if you look at the JEE Advanced results last year, our students have performed 6 to 7 times better than the other students who were in other coaching institutes. The ratio of students who are getting into IITs is much higher. And the reason for that, like I said, is the content we give, it's the strategy we give, it's the flow of the syllabus we follow, it's because of the teachers that we have, it's because of the dedication of all the content team, the back end, the support staff, the master teachers. The whole ecosystem has only one goal, and that is student learning outcome. That's it. And we have designed specialized courses for all of you. There is a crash course for 2021. There are long-term batches, and in these long-term batches you get yourself prepared for KVPY, JEE Mains, JEE Advanced, CBSE board, everything under one roof. There are micro courses, there is doubt solving, there is mock test series. All of this are the essential ingredients for your success apart from your hard work. You need that hard work, you need the dedication, but you also need the right mentorship. And that's what we give you at just 3,600 rupees per month, which are very affordable prices. If you go around the market and you look at it, I mean, the people are charging 10 to 20,000 rupees per month, because if you see the 2-year fees and all that, it's like crazy. I mean, like 4 lakhs, 5 lakh rupees for the 2-year program. But look at this. I mean, these prices are never heard of. In fact, you can also opt for personal mentorship in the plus version. So use my coupon code SHHPRO if you are interested in the long-term batches, and if you need help, please let me know in the comment section below. So let's do some recap. So for droppers, yes Steve, we are going to start the droppers batch as well. We Enthuse, why are you afraid? And yeah, I don't know, Munna bhai is Tamil or not. Okay. Let's see. Can we have test series alone, says Nitish? No. Nitish, in fact, think about it this way. You get 20 tests plus lots of assignments. Imagine you have assignments and you solve it like test series, and the lectures and doubt solving at 6,000 rupees. The link for that crash course is there below. So in 6,000 rupees, using my coupon code SHCC, you get, test series, assignments, doubts and classes. That's crazy. Hi Pankhaja, welcome aboard. So Steve, probably by the month end, and probably once the dates of the JEE Mains are announced, then we'll get a clarity. We are just waiting for the JEE Mains dates. So just hold on, Steve. Okay. Lots of homework in college. So Surya, you need to manage both of that. In fact, if you just concentrate on school or college, then trust me, your JEE preparation will go haywire. So it's very important that you guys please focus on JEE preparation more than your board examinations. It's very important. All the people who have got excellent percentile, one thing in common is that they focus more on JEE. Their boards automatically gets, prepared, and they don't have to waste a lot of time over there. Hi Sushil, nice to see all of you new out here. So guys, if you're new, please let us know in the comment section, and remember, do not forget to hit the subscribe button, because that's the only way you can get updates from all of us. And yes, please smash the like button as well. So let's get going with our class tonight. Yep. So a quick recap of what we did last time. A capacitor is an energy storing device, and the charge which is stored on a capacitor is given by CV, where C is the capacitance, V is the voltage across the capacitor. Capacitance is measured in farads, remember that, and 1 farad capacitance is when 1 coulomb of charge is stored across 1 volt of difference. And we have seen 3 different types of capacitors last lecture. One was the parallel plate. I have given you the formula epsilon naught A by D, and then we have also seen the spherical one and the cylindrical one and the special type of capacitor. So now let's get going with our energy considerations. Like we said last lecture, that capacitor is nothing but an energy storing device. Now this circuit is very important. It will come again and again in charging and discharging also. Look at what is happening very closely in this simulation, this animation. Look at this. Okay, so you have a capacitor, you have a battery, you have some circuit which takes away energy like the bulb, the fan, or some device. These are representations of some devices which consume energy. You can see when this switch is on, okay, and this switch is off, you will see the battery supplies energy to the capacitor, and when this switch is off and this switch is on, the capacitor gives away that energy into these parts of the circuit. It gets discharged and again gets charged, and again when you turn this on, it gets discharged. So you can see a capacitor stores some energy. We want to know how much energy does capacitor store, and we can also use this fact to calculate how much energy can capacitor give to the rest of the elements of the circuit. Yes. Oh, Vikas, very nice statement. Capacitor is like biceps storing power, except for the fact that capacitor can store it and restore it very quickly. Sir, capacitor is AC or DC? No, capacitor is not AC or DC. Capacitor is a device. The current which can pass through the device can be AC or DC. Right now in these chapters we are passing DC currents, but you will also see capacitor in AC circuits, and you will see you can also pass AC current through it and it will behave little bit differently, but that's for later on. Yes, so the square cross section and the area of cross section are same. No, square cross section represents, Kiran, a cross section which is, you know, equal in all the sides, but area of cross section represents how much is the actual area in meter square for that particular, you know, given figure. That area of cross section could be for anything. It could be cylindrical, it could be, I don't know, it could be square, rectangle, anything. Yes, in households you will use AC. So Sushil, I made a video yesterday, bacha. You know, all the courses which are conducted by me, I gave an action plan. I have given a list of all the books. So instead of me telling you in 20 seconds, which will not do justice, I would recommend you to watch the video. Okay, it's there. You can watch, you can skip the other parts if you want, but you can watch the recommended books, a list, etc., which I have given, you know, during that course of lecture. Now, look at what is happening. The moment you connect a battery, what a capacitor undergoes is basically taking away of the charges by the battery and it puts it on the other side. So all that a battery does is takes away some charges and puts it on the other side. Now in this process some work is done, and you know, you are taking some charge, you are taking away some charge and putting it on the other side. So there is some electrical energy stored inside that capacitor. How much is this energy? Let's do this. Let's do this. Thank you, Surya. Yes, it will be different. That's why we are here on YouTube, to make sure that you learn the best way and the most appropriate way. And we want to spread this joy of learning to all the kids around India. Now, here is the thing. See guys, try and recollect the concept from electrostatics. Okay, we had told that change in electrical energy, there was a formula given for that. Delta U is nothing but the charge which is moved multiplied by the potential difference. So if you take a charge and move it across a potential difference, the change in the energy is given by the charge multiplied by the potential difference. I hope everybody remembers this concept. Now imagine this, when there is no charge, when there is no charge on the capacitor, how much energy will be there? There will be zero energy stored in the capacitor, right? There will be no energy stored in the capacitor. But when there is Q amount of charge which is stored in the capacitor, then the energy stored is U. So U is nothing but the energy stored in the capacitor when Q charge is stored in it. Beautiful, GDB, Ankit, Surya and everyone, correct. Now let's do this process. I take some instant of time when the charge is Q. This Q is at some instant. It's at some instant. Recollect the animation I just showed you some time back. Charges are taken and put it over here. Charges are taken, put it over here. You build up the charges, and the charge which you take, okay, is dq. This is the charge which you take or which flows, okay, it flows across how much potential difference? Think about it. You are basically taking, oops, actually the direction was ulta because you are putting the positive charge here, my bad. So you are taking dq charge which is flowing. Yes, the dq charge which flows, it's taken from here. dq is the small increment in the charge. Earlier the charge was q minus q. You take away dq charge, put it here. Across how much potential difference are you taking it? You are taking it across a potential difference of V volts. Again take dq charge, put it. Again take dq charge, put it. You are doing some work and thereby increasing the energy stored in the capacitor. So guys, that change in the electrical energy will be du. Du stands for the small increment in the energy is equal to how much charge flows. Well, that's dq into what is the potential difference? That's V. Everybody clear till this point? Yes, Nihal, you're a little bit late. You just started with energy. I just gave you a brief recap and a build up to energy related, concepts. Great, great, great. Very good, Nivita. Very good, Surya. Very good, GDB. Excelente, excelente. Great. Now, Yapo says PL. Yes, Darshan. Okay. Now, remember, I have given you the formula last lecture. Q is CV. Charge is capacitance into voltage. So hence, V will be nothing but, think about it, Q divided by C, because Q is C into V, correct? Oh, I know what to do now, because on the LHS I have some derivative term, on the RHS I have some derivative term. That means I need to integrate both sides. Yep, I need to integrate both sides. What would be the limits of integration? I can get the hint from over here. When there is no charge, then the energy stored in the capacitor is 0. When there is no charge, the energy stored is 0. Lower limits. Upper limits. When the charge is Q, then the energy stored is U. When the charge finally is Q, then the energy stored is U. Therefore, what am I going to get? Well. Integral of du is just U, so it's going to be U, and then you put 0 and then subtract them. And over here, well, 1 by C is a constant, right? So constants always go outside the integral. Here you have Q dq. Well, the power of Q is 1. X raised to 1's integral is x raised to 1 plus 1 divided by 1 plus 1. What is that? X square by 2, right? That's the integral of x dx. So Q dq's integral is Q square by 2. So substitute Q square by 2 here, and then 0 square by 2 over here. And what am I going to get? I'm just going to get U is equal to half Q square by C. That's the formula. Isn't it interesting? Beautiful. Yeah. So Darun, Nurture series is for 11th, Pathfinder is for 12th standard. Okay, remember that. Okay, now you can also play around with this formula. Remember, Q is CV. So rearrange this formula in different ways, and you can see, you can just put CV over here. So C square V square, 1C will get cancelled. So it will become half CV square. You can also write it in this form. And if you do not want to write it in this form, there is one more form. You can put V is equal to Q by C, what is that? C is equal to Q by V and all that, and you will see it will be also equal to half times QV. Yep, look at that. All these three are equivalent forms. Remember that. None of them are different. They're just depending on which type of problem is given, what is given, you will use the correct formula. Okay. Yes, Sankit, I'm going to take a question right now. Don't worry. Let's solve a question. Remember, the entire derivation has been pasted for you. So whatever I write, do not worry. It's all printed and you will be getting the entire PDF in our Telegram channel. So in case you haven't joined it, please join it to get it in a PDF form. All right, so let's solve a question for all of you. There we go. If the energy stored in a capacitor of 3 farad has to be doubled, then the charge must be increased, decreased how many times? Think about it. Jabir, I think you are a little bit late, bacha. Guys, all those people who are late, don't worry. There is a beautiful feature in YouTube. And what's that? Take the slider below, scroll it behind, and watch the video which you have missed, those last 5-10 minutes at 2x speed, and catch up with us. Okay? Don't worry, you will be there very soon. Surya, I have already made a micro course on derivations, so you can join our micro courses in the pro subscription. All the derivations have been taken care of. Okay, Surya? So it's there in the pro subscription. Okay, a lot of you are saying A, Nagula, Niha, Ankit, Said Helgu saying D. Okay, interesting. Guys, what's the formula? What's the formula that you're going to use? Energy stored in the capacitor has to be doubled. So what are you going to do? Well, U is nothing but half Q square by C. That's the formula, right? And what do you have to do? You want to take this energy and you want to double it. You want to make it 2 times. That means you cannot play with this number. You cannot play with this number. You have to take q square and double it. So you have to double q square. If you have to increase q square 2 times, that means this q should be increased how many times? How many times? 4 or root 2? Obviously root 2. Because root 2's square will give you 2, right? So if you increase q root 2 times, q square will increase 2 times. Hence, it is D option. It is D option. Lot of you got it wrong. A lot of you got it wrong. That is why these questions are important, so that you understand how this formula works. Is everybody convinced? Everybody understood how this is done now? Yes, so less. Correcto. No problem, Sushil. No need to be sorry, but it happens. Understand how I played with this formula. U increased 2 times. Nothing else can change. Q square increased 2 times. That means the one quantity which is squared should increase root 2 times. That's how it is. Very good, very good, very good. Ankit, I just explained it once more. Yep, formulas got mixed. Why am I using this formula? Because Q has to be commented upon, because the question is on what will happen to the charge. Remember, capacitance does not change. It only depends on the medium, material, geometry and all that. Okay, so guys, again one more question. If imagine Q square has to increase, example, 5 times. If Q square has to increase 5 times, then how many times should Q increase? Come on, quickly write the answer in the chat box. Write the answer in the chat box. Yes, come on, think about it. Okay, Sushil has understood it now. Ankit, I think you will understand it now after this. If Q square has to increase 5 times, then Q should increase how many times? Come on guys, let me know in the chat box. Just an example. Root 5. Beautiful, Ankit. See, you got it. There you go. So this should increase root 5 times. Beautiful, 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 Ria. Beautiful, Sushil. Beautiful, PL. Excelente, Sai Telugu. Excelente, Rachna. Excelente. Let's get going to the next question. And there we have the next question up on your screen. A 16 picofarad. P stands for pico. Pico is 10 to the power. You think it's a negative power. Think. Okay, capacitor is connected to 70 volt supply. How much energy is stored inside the capacitor? Let's see how many of you can get this. Yes, Nitish, I guess so. I'm not sure about chemistry though, Nitish, but maths, yes. Okay, come on, my warriors, figure this out. Just a calculation. You need to know the formula and use it rightly. Substitute, calculate properly. Rachna saying minus 12. Beautiful. Yes, 10 to the power minus 12 is pico. Correcto. Okay, Sai Telugu says again definitely D. Okay, let's see. What's the correct answer, guys? Come on. No problem, Suryansh. No problem. I'm always there for all of you. Remember, if I'm not able to answer any of your doubts during the live chat, you can always leave a comment below in the comment section after the video ends. Okay, so let's do this. Which formula am I going to use? Capacitance is given, voltage is given. I think I'll use half CV square. Remember that formula? Yeah, I'm going to use half CV square. So U is half into C into V square. Now what is C? C is 16, but that's pico, that's 10 to the power minus 12, right? Into V, V is 70, so that's 70 square. Well, 16 and 2 goes, this will become 8 and this will become 10 to the power minus 12, and this is 70 square. 70 square, guys, you can write it as 49 into 10 to the power 2, correct? Now 49 into 8, well, that's going to be 3.92. Okay, actually 392, guys. 392 into 10 to the power minus 10, which is approximately this value. You can shift the powers and make it 3.92. Option D. Beautiful. Beautiful, beautiful, beautiful. Excellent. So now you guys get it, how energy is calculated. Now look at the energy stored in a capacitor, guys. Look at this chindi energy. Such lallu energy is stored. So can you expect capacitor to do big things? No, right? So you need a very big capacitor, very big value. This is pico, chindi capacitor this is. Okay, you need very large value if you want the energy to be in joules, megajoules, kilojoules. That's why these capacitors, when they are used in small electronic circuits, they store small energy because the requirement only is very less. If you open up the back part of your TV or computer or anything else, you'll see small capacitors are there. The currents flowing, the energy requirements are very small, and that's why you can see the energies over here are in milli or micro or sometimes in nanojoules out there. Very good, Ria, your answer is correct. Let's get going. Sorish, understand these are long-term batches. These are not fast track crash courses, don't worry. And I want everybody to understand. Sorry, just because you understand fast, don't be selfish. There are others who require some time. So I'm keeping average pace, understand that. Thank you, Nitish Kumar, so much. Yeah. Okay, so let's get going to the next one. Now this is the most important concept. Work done by battery, energy lost, and all that. See, when I tell you that a capacitor stores energy when you connect a battery, imagine this capacitor, just imagine this capacitor stored, example, 10 millijoules of energy. This 10 millijoules of energy was stored in the capacitor. Do you think this battery will do work? And will that work done by that battery be more than 10 millijoules, less than 10 millijoules, or equal to 10 millijoules? Why will the battery do work? Remember, battery is nothing but a chemical cell. So there will be some chemical energy which will be converted into electrical energy. So will that conversion, chemical to electrical energy, to supply the charges, to charge the capacitor, will that energy be more, less, or equal to 10 millijoules? Come on, think about it. Come on, think about it. No problem, Sarish. I'm glad you understood this. So, what do you think? Is it going to be more? Is it going to be less? Or is it going to be equal? Think about it. Come on, answer this question really quick. Energy stored in a capacitor is 10 millijoules. What do you think? Will the battery supply more energy or less energy? Okay, somebody is saying equal. A lot of you are saying equal. Come on, guys. Energy will be equal. Well, I hate to break this, but it will not be equal. No problem, Ishan, just replay back the session and watch it at 2x speed. Okay, it's not going to be equal. Yes. Now you'll be wondering, what the hell? I thought it was equal. In fact, let me tell you, this energy which is supplied by the battery will be more than 10 joules. I don't know how much. I'll show you also how while solving problems. Let's say it is 15 joules. Example. 15 millijoules. Example, it is 15 millijoules. Now you'll be wondering, what the hell? Battery gave 15 millijoules. Who is the thief in this problem? Who is the culprit? What is it that is causing the difference of 5 millijoules? Come on, think about it. Yes, Saitalgo already mentioned that. Correcto. Resistance, heat loss, these wires, this battery's internal resistance, all of these are the culprits. That is like service tax. Your income is 15, something went in service tax, GST, something went off. What is there in your hand is 10 millijoules. Understood now? So culprits are the resistances of the wires and the internal resistance. That's where the culprit is. Now, understand, whenever energy stored in a capacitor, some energy is lost in the form of heat because of the culprits like the resistances. Now, how do you find all these culprits? Let's see. It's very simple. The work done by the battery, okay, that's basically chemical energy, the chemical energy to the electrical energy. How much is this value? It's very simple. What is a battery doing? It is taking a charge from low potential and taking it to high potential, just like the pro subscription or the crash course does. Yes, it takes you from low potential to high potential. It's increasing its potential. So how much is the change in the energy? Delta U. Everybody knows that formula. Remember electrostatics? Yes, charge into potential difference. That's it. So the charge which flows, yes, the charge which flows multiplied by the potential difference, in this case it is nothing but the EMF. So that's the formula for the work done by the battery. Everybody clear about this? Low to high, potential difference is E volts, charge which flows into potential difference. Great, great, great. Oh, I think professor is the thief. No, I'm not the thief. Okay, great. Very good, Anlin. Excelente. Hello, Kat. Welcome aboard. And this is the most important thing, the energy equation. The work done by the battery, okay, the work done by the battery, whatever value you get, will be utilized in two things. Number one, changing the energy of the capacitor. Yes, the capacitor's energy will change. 15 millijoules, out of that 10 millijoules went in capacitor's energy. Remaining, where will it go? In heat loss. Okay, this is very, very important equation. Remember this and remember this. Two important formulas for all of you. This is like what is given to you, all right? Out of that, some of it will come in your hands. This is your GST, service tax, income tax, whatever that is. And guys, in case you're a little bit late for the session, do not worry. You can go back, scroll the slider of YouTube and catch up with us at 2x speed. All right, cool, great, great. Shall we start doing some problems? Are you guys excited to do some problems? Yep, shall we do some problems? And how do you calculate delta U? Use that formula. Which formula? Half CV square or half Q square by C. So that's what it is. I have put it up in the notes for all of you. Okay, so work done by the battery and everything else. Work done is EMF into charge and work done is delta U plus the heat losses. Everything is given. Remember capacitor's formula, energy stored is half CV square, half Q square by, oops, this 2 is extra guys. I'll make sure it is corrected right away. Okay, this should not have been there. Thank God I saw it. Okay. Yep, there you go. Cool. Let's get going to some questions right away. Yep, everybody saying yes, yo, amazing. Oh, this is your first question. There's a capacitor, capacitance C, and it is charged using a battery, all right? So question is, what is the energy lost in this process? Very important, most important question for all of you. And this is the most basic and important question to start with. First of all, after charging, how much charge will be there here and how much charge will be there here? What is the final charge? Come on guys, let me know in the chat box. What's the value of Q? Quickly let me know. Come on, I'm waiting for you. Come on, come on, come on, come on, come on. All my warriors. Yes, Shreyas is ready for war, ready for problems. What is the importance of these chapters in JEE? I'm not sure, Chitrada, what do you mean by that? Well, Catchron, for this concept, yes, this is the first class. But we started capacitors in the last class. That was lecture 1. Yes. Okay. Hello, Thimbak. Welcome aboard. Don't spam bud. Okay. Come on, guys. What's the charge stored? Yes, obviously it is CV, right? It's CV. Cool. Okay. Now, how much charge actually flows across this battery? Imagine when it was not charged, both the plates had 0, 0. Correct? So, Q charge was taken. That's why this became minus Q. And it was put over here. Q is taken and that's why it became minus Q, taken across the battery, across this voltage and put it over here. So guys, can you quickly tell me what is the work done by the battery? Remember, it is the charge which flows multiplied by the EMF. Okay, so what is the charge which has flown? Oh, that's Q, right? I mean, that's like CV into what's the EMF? Well, that's V. So it's going to be CV square. It's going to be CV square. Excellent. Is that clear? Is that clear? Everybody understanding this till this point? Hold on, guys. Watch how I solve it. A lot of you just had the values that it is half or it is twice and God knows what. Yep. Hello, Abhinaya, and welcome aboard, everyone. Now, what is delta U? It is final minus initial energy stored in the capacitor. Stored in the capacitor. What is the final energy stored? Oh, that's simple. That's half C V square. Capacitance C, voltage is V, half CV square. What's the initial energy stored? That's 0. Why? Because it was not charged before. So hence this is just nothing but half CV square. Great. Now coming back to our energy equation. What was our energy equation? Work done by battery is delta U plus heat loss. Substitute everything. What's the work done by the battery? CV square. What's delta U? Well, that's half CV square plus heat loss. So guys, what's the amount of heat loss? Isn't it? Take this half CV square there. It will become half CV square. That's our final answer. Half CV square. Padmaban, what do you think I'm doing right now? Am I not teaching for free? Am I not teaching? I mean, forget poor people. I'm teaching to rich people also right now. Yeah, everybody is welcome out here on English channel. Yeah, the Vedantu is doing exactly that. You know, why half CV square, Tarun? CV square is equal to half CV square plus heat loss. Take this half CV square on the other side. Half CV square. CV square minus half CV square. How much will be remaining? Half CV square. And this, I just gave you that formula. This is just a formula. This is formula I just gave you in the last slide. Formula in the last slides. It was just derived. In fact, I derived it. I hope you are there. Yep. Okay, Tarun. Cool. Yep. Clear. Understood. So guys, this is very interesting. You know, the battery is doing CV square work. Yeah, the battery is doing CV square work, but only half of it is getting stored. And there is one kamina, there is one evil guy, and that's resistance. It's taking away 50% of the energy, 50% tax, and half the energy is just going away. Okay, crazy. Let's do one more problem like this. Very interesting. Look at this. Very, very interesting problem. There is a capacitor. It is charged using a battery. Now the battery is removed and you connect it in reverse like shown over here. What is the energy lost in the process? Let's do this question. How much energy is lost in the process? A lot of people might think it's zero, but hold on. First question to you guys is, guys, if it is connected like this plate will be positive, this plate will be negative, this will be Q, this will be minus Q. Quickly tell me what is the value of Q. Come on, answer in the chat box. What is the value of Q? Hold on, guys. No, it's not so simple. Some of you have already said 0. You'll get 0 marks if you write 0. Come on, come on, come on, come on, come on. Come on. Yes, GDB. Yes, PL. Correct. It will be CV. Now, when you reverse the polarities, this is minus, this is plus. Do you think same magnitude of the charge will be there on both the plates, or will it be different? Should I put these charges also as Q, minus Q and plus Q, or should it be different? Come on, let me know in the chat box. Should it still be magnitude wise CV or Q only, or should it be different? Come on guys, let me know. Should it be different? No, right? It should be same because voltage is same, capacitance is same, charge will also be same. Unless I used a different battery or different capacitance, obviously charge won't change. So even this will have plus Q and this will have minus Q, the same value of charge. Now quickly answer this question. What do you think is the change in the energy of the capacitance? Come on, final energy minus initial energy. What do you think is the answer? Charge is same, capacitance is same, voltage is same. What do you think is the change in the energy? It will not be different, Ganesh, because voltage is same, capacitance is same. So magnitude wise they will be same. I hope Naomi, you understood why it is not different. Ganesh and Abhinaya and Sorish and Ria, I hope it is understood why the charges were same. Yes, correct. The answer is 0 for this, delta U, correcto. Because what will you write? Even if you had to write, I mean, come on, you will just write half CV square minus half CV square. I mean, you're going to get 0 only. Yes, delta U is 0. Okay, very good, excellent. Now, lot of you in the JEE Mains examination, you'll be like, oh, no change in energy. Oh, that means energy lost is 0. No change, nothing. That's where you go wrong. That's the stupidest mistake which most people do. Understand, that's wrong. No problem, don't say sorry. It's okay, Nagula. You are a student, you will make mistakes. If a student does not make mistakes, then he's not a student. Understand that. Yes. If there is some student who says in this world, oh, I don't make mistakes, oh, I do everything correctly, I'm pretty sure he's lying or he's not a student, he's not a good student. Okay, now comes the next part. How much charge do you think would have flown through this battery? Look at this. This plate, concentrate on this plate. Earlier, this plate had plus Q charge. Now it became minus Q. Imagine this. This plate had plus Q charge before. Now it became minus Q. So how much charge was taken away from this plate? How much charge was taken away from this plate? Q, 2Q, Q by 2. How much charge? Beautiful, PL. Abhinay, think again. Ganesh, I have conducted a beautiful lecture on units and dimensions. In fact, 3 lectures on it. Please watch it in the nurture series. It's there in the playlist. Excellent. 2Q. 2Q. Everybody knows this. Very good. I'm so happy. Some days back, people were confused. Q said minus Q. Why is it 2Q? Yes, it's 2Q. Very good. So, from Q to minus Q, 2Q charge has been taken. And if you have taken it, where did it move? How did it flow? It has flown through this battery. So 2Q charge has flown. Now it flows through the battery. So guys, think about it. What is the work? I'll just put it over here. Okay. So what is the work done by the battery? What is the work done by the battery? Charge which flows into potential difference, which is V, which means Q is CV. So just substitute that. So 2 into CV into V, which is 2CV square. 2CV square is the work done by battery. Coming to dielectric after this, Amar, hold on, have some patience. Next up, work done by battery is equal to delta U plus heat loss. Plus heat loss. So what is the work done by battery? 2CV square. What's delta U? That's 0. So plus heat loss. So guys, what's the heat loss? Obviously it is 2CV square. Many of you would not have got this answer if I had not done this. Yep. So Amar, I would request you to watch the replay again. I have explained each and every step in detail. So just go back, rewind this and watch everything in detail. All that we have done is calculated initial charge, final charge. They were same. So no change in the energy stored in the capacitor. Final and initial things are same. Okay, because the battery was same, it was just reverse. Next thing we calculated was, this plate had Q charge. Later on it had minus Q charge. So 2Q charge was taken away from it and it has flown through this battery. So work done is charge into voltage. That's what we got. And this is nothing but the energy equation which I just gave you some time back. Jayasurya Nurture series is for 11th standard. Pathfinder is for 12th standard. What are these kind of series? These are for all the students for long-term batches who are studying on YouTube. Yep. For all the students on YouTube who are studying over here on this special English JEE channel, for all of you, these are the long-term series. We are going to cover all the 11th and the 12th standard topics. Physics, chemistry, maths. Great. Now, next up, beautiful question for all of you, again based on energy. These kind of questions do come in JEE Mains, in KVPY, in BitSat, and you name it, JEE Advanced also. These are very good questions, guys. Lot of people make mistakes. You can see they are all very conceptual. So these can come in JEE Advanced single choice as well. Now, a capacitor of capacitance C is charged by a battery of voltage V. Okay. Now, it is connected. So you remove this battery, you take away this battery. That charged capacitor, you connect it to another capacitor of capacitance 2C. Okay, you connect it to another capacitor of capacitance 2C. What are the final charges and the energy lost in this process? Let's do this. Let's do it step by step. First thing first. Initially, this capacitor would be charged. So guys, this will be plus Q, this will be minus Q. Quickly think, what is the charge stored on this capacitor? Quickly guys, answer in the chat box. Come on, my warriors, figure this out. What is this? What is the amount of charge stored? Yes, very good. PL is very quick. Come on guys, be quick. All right, next up, what is the initial energy stored in this capacitor? Oh, well, that's easy. That's half CV square, standard formula. I just derived it for all of you a few minutes back. So just that's it. Okay, great. Now, when you disconnect the battery, take this capacitor and put it here. Take this capacitor and put it here. Initially, this will have plus Q, this will have minus Q. This is initial. This is initial. And this capacitor, well, that will have 0 and 0 charge. Okay, this will have 0 and 0 charge. Remember, it is connected to uncharged capacitor. This is all initial, the ones in green. Now, what will happen? These charges will flow and eventually both the capacitors will be charged. This will get slightly discharged, this will get slightly charged. But it's not like this will get completely discharged. But how much charge will flow? I do not know that. So I will use a trick. Let's just assume that on this plate, okay, plus Q charge is there and over here minus Q charge is there. This is final. The ones in the red are final charges. Can you guess how much charge will be stored on this plate? I think you should. I'll tell you how, and it's very easy guess. I'll tell you how. Look at this particular system. Look at this particular system. Look at this system. Tell me one thing. Isn't this system completely separated from other parts of the circuit? Because there is an air gap. There is nothing which can come in, nothing which can go out of the system. Can I say this is isolated system? Can I say this is isolated system? Yes, Kat, you're going to get even the questions, the theory, whatever. Yep, it's going to be there in the PDF. Yes, it's an isolated system. And what is the speciality of isolated system? The charge is conserved. It cannot go out. It cannot go in. It's like a locked room. Nothing can go out. Nothing can come in. So the total charge, all right, is constant. It's constant. That means earlier the total charge was how much? How much was the total charge before? Initial Q plus 0 is Q. That means the total charge Q must be constant. Hence, if the final charge on this guy is small q, how much charge must be there on the other side? How much charge must be there here? Obviously Q minus Q. Yes, so this will have Q minus Q charge on this side. Is that clear? Jagdish, how does it matter? Eventually all the chapters will be completed, right? Yeah. Why I taught this? Because I feel that current electricity should be taught before. Because of that I taught it. Yes, Q minus Q. Beautiful, beautiful. Excellent. And on the other side, what are you going to have? Obviously minus Q, minus Q. If whatever positive value, the negative of that will be there over there. Okay, don't worry. Now that's it. That's all I need. And look at this. Whatever voltage will be there across this capacitor will be the same voltage across this capacitor. Why? This point and this point, think about it. This capacitor is connected to this point. This capacitor is connected to this point. This capacitor is connected to this point. That capacitor is also connected to that point. So can I say potential difference for both capacitors is same? Both capacitors is same. Isn't that true? Isn't that true? And what is the formula for voltage difference? Well, voltage difference is charge divided by the capacitance. Remember, Q was CV, so V is Q by C. So use this fact. Both of them have the same voltage difference. The voltage difference is same. Jagdish, first learn the basics before going to Irodo. Lot of people try to run a marathon on the first day and they faint off. So Jagdish, warning, don't try and do Irodo right now. It's not the time, it's not the correct time. That's why many people, they get confused, they have wrong concepts. So hold on, first learn the basics. Okay, so what's the voltage difference? Well, that's going to be Q by C for this capacitor, charge by C for this capacitor, which is also equal to the charge on this capacitor upon the capacitance, which is Q minus Q divided by 2C. Everybody clear till this point? Yes, yes, yes. Now, just cancel out the C, take that 2 on the other side. So 2Q will be equal to Q minus Q, and take this Q on the other side, so it will become 3Q is equal to Q. Therefore, you are going to get, and by the way, this Q, we already saw it was nothing but CV from there, correct? So therefore, Q is equal to CV by 3. We figured this out, guys. Yes, the charge on the capacitor is CV by 3. Naturally, on the other capacitor, it will be 2CV by 3. 2CV by 3. Everybody clear? Everybody understood how to solve this question? Everybody understood how to solve this question? So we have equated the potential difference. We have conserved the charge. So two very important concepts. Charge conservation, potential differences are equal, and then just using Q is equal to CV, nothing else. Now, the last step in this problem is obviously, before going ahead, what will be the voltage? What will be this voltage? Well, you can find out this voltage, which is charge, which is CV by 3, divided by capacitance. So it will be nothing but V by 3, correct? So the final voltage, so what is this? This is the final voltage which is across the capacitor. Okay. Now the question is still remaining, how much energy is lost in the process? Let's do this. What will be the final energy stored in the capacitors? Just think about it. It will be half C V by 3, because that's the final voltage square, okay, plus even this capacitor is charged, all right, so half, but that capacitance is 2C into voltage is going to be same, so V by 3 square. Yes, both the capacitors will have the same voltage. Keep this in mind. Last thing, I'm going to remove all of this. It's no longer needed. It's no longer needed. Okay, let's solve this. What is delta U going to be? What is the change in the energy going to be? Think about it. Think about it. This minus this, just subtract the 2. Yes, just subtract the 2, guys. So delta U will be nothing but final minus the initial energy. Yes, just the final minus the initial energy. Just do that. So final energy is half C V by 3 whole square, means V square by 9, plus half into 2C V square by 9 minus this initial energy, which is half C V square. Half C V square I can take out as common. Half C V square is common. So I have 1 by 9 plus 2 by 9 minus 1. Check this out. 1 by 9 plus 2 by 9 minus 1. Half CV square has been taken out common. 1 by 9 plus 2 by 9, well, that's 3 by 9, correct? And you can cancel this. This will become 1 by 3. 1 by 3 minus 1 is minus 2 by 3. So this will become half CV square into minus 2 by 3. You can now cancel out few things. This 2 and 2 goes, and hence this is nothing but CV square with negative sign by 3. That's delta U. Delta U. Guys, once this is done, tell me one thing. No, not low battery. In fact, there is no battery. What is the work done by battery? Guys, there is no battery only over here. If there is no battery only over here, work done by battery is 0. This delta U is negative. What does it tell? What does it tell? If delta U is negative, it means energy has decreased. Yes, energy has decreased. If energy has decreased, where has it gone? Heat loss. So what is the energy lost in the process? Come on, type it out in the chat box. I am waiting for it. If this is the amount of energy which is decreased, what's the energy lost in this process? Ananti, if you have just entered into 12th standard, you should start with our Pathfinder series, not Flash series. Flash series is for those students who want to do it like more like a crash course. So start from electrostatics, Gauss law, current, electricity, and come over here. You might take few weeks, but do it properly. Okay, cool. So Catherine, why don't you put up your comments after the video? I will make sure that somebody replies to that later on. Yes, yes. Oh, why is it CV? It's CV square by 3 only. It's not CV, guys. It's CV square by 3. Oh, I'm not energetic. No, Vijay Kumar, I'm very energetic. It's a big problem, so I have to explain it step by step. Yes. So the energy lost in the process is just CV square by 3. So this loss, this negative value tells that it is lost. It has decreased. So the amount which has decreased is basically lost, and that's CV square by 3. That's the answer. Great. Now let's talk about the next thing, which is energy density. Okay, just 1 second, guys. Okay, so what is energy density? Well. 1 second. Okay. Yep, I'll show it to you over here. So if you have a capacitor, we know that there is electric field inside that capacitor. Correct? There is electric field inside that capacitor, and the capacitor stores the energy in the field. I am now interested in what is the energy density. What is the energy density? The meaning of energy density is how much energy is stored per unit volume wherever the energy is stored. How much energy is stored per unit volume? And that's very simple. This can be written down as, observe this carefully, energy stored in a capacitor. What's the formula? Half CV square. Half CV square is the energy stored inside a capacitor. Volume, that's area into the distance. Area is A into D. That's the volume. Remember, the area of cross section is A multiplied by the distance between the plates. So I'll show it over here. This is the distance between the plates. This is the area of the plates. So that's the volume. Next step would be, okay, observe the derivation carefully. Okay, just observe the derivation carefully. C, which is capacitance. I gave you the formula last class. It was epsilon naught A divided by D. That's the value of capacitance for parallel plate, into V square divided by A into D. Now the best part about this, well, this A and this A gets cancelled, and now I can simply write this as half epsilon naught, okay, epsilon naught, D into D is D square, so it is nothing but V by D whole square. Now guess what this electric field is? Electric field is nothing but dV by dr, which is nothing but voltage difference by distance. What is the voltage difference? It's V. What's the distance? D. So isn't this V by D actually E? Isn't this electric field actually V by D, voltage by distance? So what are you going to get? You are going to get half epsilon naught E square. That's the energy per unit volume. This is very, very important formula. Energy per unit volume, please understand the units for this will be joules per meter cube. Energy per unit volume, half epsilon naught E square. Yes, potential gradient, correct. Everybody clear? Shall we start solving some problems based on this formula? Hello sir, I am Rashmi from class 11th NEET. Yes, just Jatin, you can watch the lectures, no problem. You watch the Nurture series, don't watch the Pathfinder series. Pathfinder is for 12th standard, 11th to 12th moving, who are going to give the examination next year, or even those students who are writing the examination this year and they want in detailed explanations of all the chapters. It's for them. Hamsadwaj is asking me to speak Kannada. Kannada. Ninnu Heserenu. I think that means what's your name? Nanna Hesarenu Shreyas. Okay, cool. Yeah, cool. Let's get going, and you should know all these things. Okay, great. By the way, this derivation is also provided in the PDF. Don't worry about it. Okay, yeah, there you go. That's the derivation. Okay, now let's, oops, the derivation is coming like this. Okay, so all of this will be provided to you in the Telegram group. Don't worry about it. Okay, let's see whether you can solve this question. In a charged capacitor, the energy stored is in which of the following? Only one of them is correct. Sorish, my age is a mystery. Hi Ojasvi, welcome aboard. Come on, all my warriors. Vignesh says D, Sai Telugu says A. Is A always constant in the formula? No. E can change. E is a variable. So if E changes because of some reason, then even the density at different points could be different, Jay Ajinkya. Okay, PL says D. Okay, many of you are saying D, or some of you are saying A, and one of you also said C. Well, the correct answer is actually electric field between the plates. I just told you, energy is stored between the plates of the capacitor. It's always stored inside the electric field. If there is no field, there is no energy. Obviously, there is no energy stored here. Energy is stored only in that field wala region, nowhere else. Excellent. Let's see how many of you can actually do this question. I will be very happy if you do this question. Sashidhar, why don't you leave a comment? I will definitely reply to you, okay? Or ping me on my Instagram handle. I'll give you all the list of the books, okay? Rather than me telling you over here. Just comment after the video ends, okay? For all the 11th standard, don't worry, okay? Confirm you only told, sir. Okay, come on. All my warriors, think. B, D, C, my warriors are confused. Come on, my warriors. Abhinay is saying B. Look at that. My warriors are confused. There is a point charge at some distance R. What is the energy density going to be proportional to? Neha saying B. Abhi saying B. Sorish saying B. Ojasvi saying B. GDB saying B. Sai Telugu saying, I don't know, 1 by A. Come on. I just gave the formula for energy density. Energy density. Please remember that. Okay, let's get our point charge first. That's our point charge. Guys, if you are at some distance, okay, R, at this point, what's the formula for electric field? It is nothing but K, that Coulomb's constant, into charge divided by R square. That's the formula for electric field. Now, what's the formula for energy density? I just gave you that. Energy density is half epsilon naught E square. That means this will be half epsilon naught K Q by R square. That means it's something which I don't care about. Something divided by R square is R raised to 4, which means the correct answer is D. Yes, that's the answer. Understood. Oh, very few people gave the answer. Look at that. All of you, most of you gave wrong answers. Understood? That's why I told, let's see how many of you can give the correct answer. It's simple. This is formula based. So if you know the formula, you will get it, but be careful while substituting, while doing this maths, while squaring and all that. Yeah, the correct answer is D. Oh, people started crying. Hello, Lakshmi. Yes, you have marked your attendance, I guess. How pi came? What do you mean by how pi came? I'm not sure what you mean by that. Okay, before going ahead, let me also tell you guys, in our, a lot of people keep asking, sir, what's the difference between YouTube and your Vedantu platform? Do you conduct classes on Google Meet? People have been asking that. Sir, are your classes on Zoom? Because our offline coaching institute conducts classes on Zoom or Google Meet. Nah, guys. Zoom and Google Meet is for noobs, not for us. Yeah, we have a proper product team. We have people who have worked on the software for a long time, and they have got 20 patents just on the Wave platform. This is how it looks like. It has quizzes, it has animations, it has chat box. There are 2 teachers, one teacher you can see, another teacher you cannot see. That teacher handles small groups and solves all their doubts which the students post in the live class. And you know, all these classes are interactive, engaging, and also with quizzes, and all the data points are collected where you know you can analyze even after the class how your performance has been, and you can think where you are going wrong. And this self-analysis, this kind of reports helps those students who are very much interested to know, you know, is something going wrong in my class? Is, you know, am I not doing well? Or sometimes students are very overconfident. Oh, I'm doing really well. And then that is actually a mirror to all the students that, hey, you know what? You've not been participating. That's maybe you should improve on that. So all these things happens in the Wave platform. So it's quite different, guys. Next up, dielectrics. Where am I going? Vingesh. I will conduct few classes for NEET students on catalysis. Okay, but this channel is mainly for JEE students. But yes, if you're a NEET student, you can watch these lectures out here. Okay, but we can't unmute ourselves on the Wave platform. Yes, Jagdish, you can't unmute by yourself. If the teacher is, if you request the teacher and if the teacher permits to do so, then you can unmute. In fact, in my classes, I unmute some students. We also sometimes, uncam the students, and students can see each other. In fact, you know, last year I did this. I uncammed a lot of students and then showed their talents. One of them was singing, one of them was showing their paintings, one of them was showing their artwork. All of this happens in the classroom. Okay. Yeah. Okay, thank you, Queen Ayushi. Thank you so much. Okay, let's do this. Let's see dielectric and capacitors. Now we have seen that a dielectric material is nothing but, you know, something which reduces the electric field. So if in vacuum the electric field is E, then when it goes inside the dielectric, well, the field reduces K times. That number of times the field reduces is called as the dielectric constant of that material. Great. Now guys, let's have a look. What happens is, once you put a dielectric, because the field reduces, in order to compensate for the reduction in field, more charge gets stored on the plates of the capacitor. I'll repeat, because when you put a dielectric, the field tends to reduce. In order to compensate for the reduction in field, more charge gets stored on the plates of the capacitor, and hence the effective capacitance increases K times. Now remember this, all formulas has epsilon naught in the numerator. So if you fill the capacitor with a dielectric, then the capacitance will increase how many times? K times. Remember that. Okay. Oh, it's Ojasvi's birthday. Have many happy returns of the day, Ojasvi. God bless you and all the best. Keep rocking and keep attending all the sessions live out here. Right, let's get going. Let's get going to this question. There is a plate, that means a dielectric. Insulating plate is nothing but a dielectric. It's put here. So what do you think will happen to the direction of the current? Oh my God, I shouldn't have done this. Oh, I shouldn't have done this. Okay, come on guys. Let's see. An insulating plate is passed between the plates of a capacitor. Then the current will, think what is going to happen. Well, see, when you put this slab, okay, when it is entering, what will happen? The capacitance will increase because you are putting it inside. But when it is exiting, how will it exit? Because you put it in, slide it, and it will come out. So when it exits, then the capacitance will decrease. Now that is the whole catch of the problem. Remember, the voltage is constant. That's given. Voltage is constant. You are applied the same voltage. That means, what does it mean? Q is CV, right? Q, charge is C into V. V is constant, so if C increases, the charge will also increase. But when it exits out, then the charge will decrease. That's it. Now think about it. Over here, while you are putting it in, if this charge increases, how will this charge increase? There is only one way. If the current flows like this. If the current flows from A to B in that capacitor. Do you see that? So if the current flows from A to B in that capacitor, only then this charge will increase. Next up, when you remove that slab downwards like this, it is exiting. You can see the charge is reducing. So all these charges which were there, these charges are vanishing. So understand, if the charges are going away, that means the current is going like this. That means from B to A. That's how it is. That's how it is. Everybody clear? Everybody clear? That's why the correct answer is option C, guys. First it flows from A to B and then from B to A inside that, in that capacitor. Everybody fine? Done, done. Shall we go ahead to the next question coming up on your screen? Let's do this. Okay. Anyways, I think some of you saw the answer before. No problem. Let's see. Guys, come on. Yes, please concentrate on the class. Yeah, very important concepts coming up. There is a slab which is inserted inside a capacitor. Okay. Now the question is, find the work done by the battery, change in the energy stored, and comment on the remaining energy. Let's do this. Not a big thing. Not a big thing. Okay. So first thing first, without the slab, okay, without the slab, what will be the capacitance? It's clearly mentioned. It is 5 millifarad. 5 millifarad is the capacitance. Quickly answer, what do you think would be the, yes, quickly answer, what do you think will be the charge stored on the capacitor? What do you think will be the charge stored on the capacitor? This is initially. What will be the charge stored on the capacitor? CV, right? Yes, use that formula, CV. Capacitance is 5 milli, okay, 5 milli into voltage is 10 volts. That's going to be 50 millicoulomb. Yep, CV, but substitute the value C into V. So 50 millicoulomb. That's the initial one. What is the initial energy? This was initial charge, initial energy. Initial energy stored will be half CV square. Just do that. Half into C. C is 5 milli into V. V is 10 square. Well, 10 square is 100. 100 by 2 is 50. 50 into 5, that's 250. So 250 millijoules. That's your initial energy. This is your initial charge. Okay, this much is done. Now, with the slab, with that slab, what will be the new capacitance? I just told you, whenever you put a slab, the capacitance increases K times. What's the value of K? It's 2. So the new capacitance will be 10 millifarad. That's the only change. Now calculate what's the final charge. Well, CV again. C into V. That's going to be 100 millicoulomb. Next, final energy stored. Yes, correct. Final energy stored. Again, half CV square. Half C, C is 10 milli into voltage, that's 10 square. Well, that's 1000 divided by 2, which is 500 millijoules. That's your final energy which is stored. This is final charge. Now, think about it. What's the work done by the battery? Let's do this. Oh, how much charge actually flows? Think about it. How much charge actually flows? Look at the difference. The final charge was 100, initial charge was 50. How much charge do you think actually flows? Flow. How much charge has actually flown? Yes, exactly. 100 was there afterwards, 50 was there before. So extra 50 was added. That means the flow of the charges was 50 millicoulomb. Is that clear? 50 millicoulomb has flown. So what's the work done by the battery? Work done by the battery, charge into EMF, which is 500 millijoule. That's the work done by battery. Last step, we have found out almost everything. Work done by the battery, change in the energy stored, we can find that out also. Change in the energy stored, 500 minus 250. How much is remaining? 250 millijoules. 250 millijoules. The last step over here is, remember, work done by battery is delta U plus the losses of energy. So what is the work done by battery? I just got it. It's 500. What's delta U? I just got it. It is 250. And what's the loss? From this, you will get the loss of energy is, take that 250 on the other side, 250 millijoules. Exactly. That's the answer. So, you need to go step by step. You need to think of the situations before, after, calculate every single parameter using the formulas, find out the differences, use our energy equation. Nothing can stop you. Ankit, without the slab. So without the slab, understand, you know, the original capacitance was already 5 millifarad. So just forget this green part. Okay, this green slab. So capacitance is 5, charge is CV. So used CV formula, you got initial charge, and then use the initial energy formula, or just energy formula, which is half CV square. Half CV square. That's it. I got the initial energy. That's it. Okay, cool. I hope you got it now. Yep. Now, the last two things before we end the class. This is the most crucial part of this class. Guys, if you understand the next two tables, you have understood and mastered this topic. Trust me, all the basic concepts, all the important concepts, all the variations you have understood. This is very, very important. Come on, follow me and help me out. Okay. Now, what is it? You have to fill this table. We are going to fill this together. And there are different things that are going to happen. What kind of things? The distance between the plates is going to increase. Area of the plate is increasing. There is dielectric material which is added. And this capacitor is connected to some battery. Let's think what will happen to capacitance, charge, voltage, energy, and field. All the things, everything. If you know this table, if you know how to solve this, that's it. Trust me, you will understand everything. First thing, because it is connected to battery, I think what will remain constant is the voltage. So this will not change. No matter what you do, the potential difference will remain same. Everybody gets this? Everybody gets this? Yep, I hope this is clear. The voltage will remain same because, come on, the battery is the same. Nothing can change the voltage difference. That's very simple. Next up, I think I should go with capacitance first. Let's see, what is the formula for capacitance? The formula for capacitance was epsilon naught AK divided by D. That's the formula. Distance is increased, denominator increases, capacitance will decrease. Correct? Next, area is increased, numerator increases, capacitance will increase. Next, dielectric is added, numerator increases, so capacitance will increase. Cool? Simple? Next up, charge. Charge is CV. That's the formula. But voltage is constant. So if V is constant, whatever happens to C will also happen to charge. That means, understand, if capacitance decreases here, charge will decrease. If it increases here and here, it will also increase again. That's it. So simple. Okay, great. Next up, potential energy stored inside the capacitor. Since voltage is constant, I would prefer using the formula half CV square. Yes, let's use half CV square. Okay, observe this. Now, V is constant, so don't worry about it. Whatever happens to C will also happen to energy. So whatever happens to C, okay, C decreases, increases, and again increases, will also happen to energy. That's it. Isn't it simple? The last step, electric field, I will use V by D formula. V by D is delta V by delta R, so it's voltage difference gradient, all right, the voltage gradient. Now, remember, V is same everywhere. In the first situation, the distance is increased. If you increase the distance, V by D will decrease, so field will reduce. Field will reduce. Isn't that simple? In the other two situations, neither V is changing nor D is changing. Only in the first situation, distance changed. So in these two situations, nothing will change. Is this understood? So easy. If you know how to solve the questions, trust me guys, I mean, nobody can stop you from this. Nobody should be able to stop you. Do you want to do one more problem before we wind up the class? and this is it. Okay, let's do this question. Look at this. Let's see. Yeah, enjoying this? Did you guys enjoy this question? Filling up the table. Let's do this. Look at the change. The capacitor is charged but not connected to the battery. There is no battery. I'm so sorry. Okay, my bad guys. This line shouldn't have been there. There is no battery over here. This line is extra line. It's not connected. Okay. This line shouldn't have been there. Let's do this. Now, when you do not have a battery, voltage won't remain constant. Charge will remain constant because charge has nowhere to go. Where will it escape? Nothing is there here. There is no device, resistor, battery, nothing. So charge will remain constant. Rest everything is almost similar. Capacitance is epsilon naught K A by D. Look at that. Distance increases. Denominator increases. Capacitance will reduce. Area increases. Numerator increases. Capacitance increases. Dielectric is added. K increases. Numerator increases. Capacitance increases. Great. Then voltage. V is Q by C because Q is CV. So V is Q by C. Whatever happens to capacitance will be exactly opposite to what happens to voltage because they are inversely related. Charge is constant. So if C decreases, voltage will increase. If C increases, voltage will decrease and decrease over here. Is that clear? Everybody getting it? Very good, Neetu. Very good. Following up and catching up with me. Very good. Very good. Now for you, I will not use CV square. Why? Because C and V both are changing. In fact, I will prefer using the formula half Q square by C because Q is constant. That's why I'm preferring this formula. Now look at that. C is again in the denominator. So if C decreases, denominator decreases, U will increase. So whatever happens over here will be exactly opposite. So decrease and then decrease, like you can see over here. Next up, electric field. Well, for electric field, I have two options like V by D, right? But there is a problem. In the first situation, look at this. The first situation out here, okay? The voltage is also increasing. Distance is also increasing. Voltage is also increasing. Distance is also increasing. Both are proportionately increasing. So what do you think will happen to the ratio? Think about it. Quickly answer in the chat box. For the electric field, voltage is also increasing. Distance is also increasing. So what will happen? It will be constant. Yes, it will not change. Correct. Now, for the next part, area is increased. Okay. You are changing the area. That means D is constant. Voltage, what is happening to the voltage? Voltage is decreasing. Oh, if voltage decreases, this ratio will also decrease. D is not changing at all. So that means this should also decrease. Alright, this should also decrease because V is decreasing like we figured it out here. And distance is not changed, only area is changed. And for the last part, look at that. Voltage decreases, distance is not changed. So again this one, it will decrease. Is that clear? Okay, correct. This is how you need to solve the questions. This is how, capacitors have to be studied. Not many people know how to study capacitors because there are a lot of concepts, but I have broken it down systematically into different parts. A lot of people study capacitors after Gauss's law. I do not like it. I prefer studying capacitors after current electricity. Now you will slowly understand why I have taken capacitors after current electricity. And in the next class, we are going to do series, parallel, combination in capacitors, plate problems. There are beautiful problems to find equivalent capacitances. So in lecture 3, we are going to talk a lot about finding equivalent capacitances and how to apply KVL, KCL also in circuit related problems which involve capacitors. Now this is your homework question. I'll be reading all your comments. Let's see who are the quick ones who will answer it in the comment section. And this is your second homework problem. Okay, you can take screenshots, you can also replay and get back these homeworks. And this is your third homework problem. These are 3 problems. So post up all the comments as soon as possible. I'll be reading all your comment section. Yep. And remember guys, if you want to learn under me, if you want to get all my micro courses, if you want amazing master teachers, and if you want to study in English, and there is also an option to study in Hindi, and guys, if you want test series along with KVPY preparation, JEE Mains, board, advanced, crash courses, everything involved in one single platform, and that too at 1/5 to 1/6 of the price which has been offered by most of the other institutes and which do not give half the things, and you want the replays and the notes, then you should consider joining the pro subscription right away. Already you are delaying your decision. Remember, already some 4-5 batches have started. Now this is the next batch, which is 14th June batch. So guys, you will, if you delay your enrollment, I think you will be losing out on a lot of lessons, or when you join late, the syllabus will also end late. So I feel you should start early, end early, prepare and revise with mock tests towards the end. And remember, there are these 3 packages, and each package is very affordable depending on what features it offers. The only difference in these packages is whether you want a personal mentor or do you want doubt solving. Rest everything is same. You also get the Tattva module with hard copy, soft copy in all these kind of packages. Like you can see, these are the prices which your normal tuition teacher will charge you, any local tuition teacher for English, history, physics, maths or something like that. And these prices are the ones which we are offering for so many things. So go ahead, use the coupon code SHHPRO to avail this discount. Thank you guys very much. Yes, catch sudden, my micro courses are available. In fact, I made a video on that yesterday. You can go ahead and check it out on our channel. You can see it's right over here. It's right over here. Yep. You can see all my micro courses revealed. So you can have a look at this lecture in detail out there. Thank you guys very much for tuning in. Bye bye. Take care, and please do not forget to smash that like button down there and hit the subscribe button if you are new to this channel. This was Shreyas here, your master teacher. Hasta la vista.